Welcome to Still Science Lab. Tonight, we are going to descend into the cold, subterranean tunnels of the Large Hadron Collider to confront a terrifying anomaly that violently challenges our most fundamental understanding of the physical world. We are going to explore the chilling reality of what happens when human engineering pushes the fabric of space and time past its breaking point. We operate under the comforting delusion that the universe is a finished, stable architecture. But recent data emerging from the world's most powerful particle accelerator tells a vastly different, much darker story. CERN found something that shouldn't exist, and the terrifying implication of this discovery is that it fundamentally breaks reality. We are not just observing the building blocks of matter, we are actively resurrecting chaotic, impossible structures that the universe intentionally buried in the dark, forcing us to reckon with the horrifying fragility of our own existence. We walk through our lives entirely dependent on the unyielding assumption that matter is permanent, stable, and well-behaved. We look at the periodic table of elements, we feel the solid weight of iron, we breathe the predictable molecules of oxygen, and we intuitively believe that the physical substance of the universe has always been exactly this way. We think of the cosmos as a cooled, calm, and highly regulated machine. We acknowledge that the Big Bang was a chaotic, unimaginably violent explosion of raw energy, but we psychologically distance ourselves from it, placing that primordial fire 14 billion years in the strict, inaccessible past. We desperately need to believe that the fiery, unstable youth of the universe is permanently over, and that reality has long since settled into a safe, frozen, rigid configuration that allows biological life to flourish. We assume that the laws of physics are locked in, and that the fundamental particles we interact with today are the absolute, only configurations allowed to exist. But this sense of permanence is an absolute macroscopic hallucination. The stable matter that makes up your body, your planet, and the stars in the night sky is not the default state of the universe. It is the exception. It is the cold, exhausted, and highly sanitized leftover of a much more terrifying, chaotic reality that we have deliberately decided to wake up. To understand the sheer existential dread of what CERN has actually accomplished, you must understand that the Large Hadron Collider is not merely a microscope. It is a time machine, and it operates through the application of unprecedented, localized violence. When the massive superconducting magnets accelerate heavy ions, like the incredibly dense nuclei of lead atoms, to 99.9999% of the speed of light, and violently smash them together, they are not just breaking matter apart to see what components fall out. They are generating temperatures that are hundreds of thousands of times hotter than the very core of our sun. In that infinitesimally small, localized microscopic point of impact, the fundamental forces that hold modern reality together completely melt away. The rigid, dependable boundaries of protons and neutrons literally dissolve, and physical matter is violently liquefied into a terrifying, frictionless, primordial soup known as quark-gluon plasma. This is not a substance that belongs in our modern universe. This incredibly dense, searing liquid is the exact state of reality as it existed just millionths of a second after the Big Bang. In this state, the strong nuclear force, the unyielding glue that keeps the atoms of your body from flying apart at the speed of light, is completely overwhelmed by the heat. Quarks and gluons roam freely in a chaotic, boiling storm of unbound energy. For a microscopic fraction of a millisecond, deep beneath the Swiss-French border, The scientists at CERN are literally recreating the violent, chaotic womb of the cosmos. They do this because they want to study the fluid dynamics of the early universe, treating the absolute destruction of matter as a routine data collection exercise. But when you artificially recreate the conditions of the primordial fire, you do not just get the fire, you get the monsters that used to live in it. In 2022, while meticulously sifting through the petabytes of digital wreckage generated by billions of these heavy ion collisions, physicists operating the CMS detector found a specific, undeniable signal hiding within the chaotic, swirling aftermath of the quark-gluon plasma. They found a microscopic, fleeting architectural configuration of matter that completely defies the standard rules of our modern reality. Out of the billions of collisions, they successfully isolated the digital footprints of a swarm of entities known simply as X particles. These are not protons, they are not neutrons. They are highly exotic, bizarrely configured subatomic structures that literally should not exist in the cold, stable environment of our present-day universe. They are impossible, fleeting ghosts, possessing an internal architecture so complex, so violently heavy, and so foreign to our current physical laws that theoretical physicists are still struggling to mathematically comprehend how their internal components are even temporarily bound together. The X particle is an entity that only existed naturally in the absolute first, most chaotic, microscopic fractions of a second after the universe was born. In that unimaginable primordial heat, the universe was a violently shifting, unstable storm of exotic matter, constantly boiling and churning with impossible configurations that flickered in and out of existence. But as the universe rapidly expanded, it was forced to cool, and as it cooled, it underwent a violent, unforgiving cosmic phase transition. To create the stable, predictable reality we inhabit today, the universe had to actively eradicate these chaotic structures. It had to permanently freeze the quarks into the rigid, dependable formations of protons and neutrons that make up the periodic table. It had to actively bury, cool, and destroy the X particles, locking them away in the dark, inaccessible past, so that the delicate, incredibly complex chemistry required for biology could eventually emerge. The X particle is a piece of reality that the universe intentionally deleted in order for us to exist. This forces us to confront a deeply paralyzing, terrifying realization about the nature of the modern scientific endeavor. We are not just passive observers taking notes on the physical world from a safe distance. We are aggressively, deliberately forcing the universe to remember its most violent, unstable origins. By artificially recreating the quark-gluon plasma and summoning the X particle out of the primordial void, we are essentially digging up the foundational graves of the cosmos. We are dragging the chaotic, hostile architecture of the Big Bang kicking and screaming into the present day. We operate under the blind, arrogant assumption that we can perfectly control these localized resurrective events, that we can spark the primordial fire inside a magnetic cage, take our precise measurements, and let the anomalies safely decay back into nothingness without consequence. We treat these impossible particles as mere mathematical curiosities, completely ignoring the horrifying philosophical implication of their return. We are violently testing the memory of the universe. We are forcefully unwriting the 14 billion years of cooling, expansion, and stabilization that separates our fragile biological existence from the screaming, chaotic abyss of creation. The existence of the X particle inside the detectors at CERN is a stark, physical reminder that the solid, dependable reality we trust with our lives is incredibly precarious. The chaotic, exotic configurations of matter that defined the violent birth of the cosmos are not permanently gone. They are simply dormant, hiding just beneath the surface of our frozen world, waiting for enough heat and kinetic violence to wake them up. We have successfully reached back to the dawn of time to pull a primordial monster out of the fire, and in doing so, we have physically proven that the rigid, unbreakable laws of our modern reality are nothing more than a temporary, localized illusion. We are living on the cooled, hardened crust of a cosmological volcano, and our brightest minds have deliberately decided to start drilling directly into the magma just to see what kind of impossible, terrifying things are still swimming in the dark. We desperately cling to the psychological armor of absolute taxonomy. We possess an overwhelming biological need to categorize, sort, and label every single aspect of the physical world, placing the chaotic elements of nature into neat, rigid, and deeply predictable boxes. We look at the periodic table of elements and feel a profound sense of rational security, believing that we have successfully catalogued the definitive alphabet of existence. We assume, with supreme arrogance, that the universe operates according to a strict, unbreakable set of architectural blueprints, and that the fundamental matter composing our bodies and our world is bound by permanent, unyielding laws. We believe that physical reality is a finished product, a static, unchangeable machine that simply follows the rules encoded into its foundation since the cooling of the Big Bang. But the terrifying data bleeding out of the subterranean detectors at CERN completely shatters this comforting illusion of stability. The machines we have built are not just reading the cosmic blueprint, they are actively, violently forcing the universe to rewrite it. We have discovered that the physical substance of reality is not fixed, and under the extreme, unprecedented torture of our particle colliders, fundamental matter is actively mutating, inventing unnatural, alien configurations that literally defy the classical rules of existence. To understand the sheer, paralyzing horror of these forbidden configurations, we must first look at the absolute, dogmatic rules that have governed particle physics for more than half a century. When you strip away the familiar macroscopic world of cells, molecules, and atoms, you are left with the absolute basement of physical reality, the quarks. Quarks are the fundamental, indivisible building blocks of all known matter. But quarks are subjected to a bizarre, tyrannical rule of quantum mechanics known as color confinement. Unlike electrons, which can float freely through the vacuum of space, a quark is strictly forbidden by the laws of physics from ever existing in isolation. The strong nuclear force, the unimaginably powerful cosmic glue that holds the nucleus of an atom together, binds quarks with an unyielding, unbreakable tension. If you try to pull two quarks apart, the energy required to separate them becomes so incredibly massive that it literally snaps, instantly converting that raw energy into brand new quarks, which immediately bind together again. You can never hold a single quark in your hand. They must always exist in a group, perfectly balanced and tightly bound in the dark. And, for decades, the absolute, unquestioned law of the Standard Model dictated that quarks were only mathematically permitted to group together in exactly two specific, highly regulated configurations. They could form pairs, a combination of one quark and one antiquark, creating a highly unstable, fleeting particle known as a meson. Or they could group together in triplets, a stable, permanent trinity of three quarks bound in perfect harmony, creating the protons and neutrons that make up the vast, overwhelming majority of the visible universe, including every single atom in your biological body. 2 or 3. That was the absolute, unbending rule of physical reality. For 50 years, every particle ever discovered, every atomic structure ever measured, and every piece of matter ever observed in the cosmos perfectly obeyed this rigid mathematical limitation. Physics textbooks were written, careers were built, and our entire understanding of the material world was anchored to the comforting certainty that quarks do not, under any circumstances, assemble into larger, more complex structures. 4-quark or 5-quark combinations were considered mathematically forbidden, unnatural anomalies that the universe simply did not allow to exist. But the Large Hadron Collider is not a machine designed to respect the classical rules of physics. It is a machine designed to subject the fundamental fabric of reality to a level of sustained, hyper-concentrated violence that defies all human comprehension. When the superconducting magnets hurl protons into a head-on collision at 99.9999% of the speed of light, they are doing something far more terrifying than simply breaking a particle apart. They are actively torturing the strong nuclear force. They are taking the absolute, fundamental glue of the cosmos and subjecting it to a localized kinetic trauma so intense, so brutally unforgiving, that the standard, comfortable rules of quantum confinement completely break down. Inside the blazing, microscopic epicenter of that crash, the temperature spikes to hundreds of thousands of times hotter than the core of the sun, and the quarks are violently ripped from their stable trinities, thrown into a chaotic, searing storm of raw, screaming energy. It is entirely within this microscopic torture chamber that the absolute nightmare of mutating matter physically manifests. When the scientists at CERN sifted through the digital wreckage of these catastrophic collisions, searching for the predictable, standard model debris of mesons and baryons, they found something deeply, profoundly wrong. The massive electronic detectors began to pick up the undeniable signatures of massive, impossible entities. They found particles that were too heavy, too complex, and architecturally too bizarre to be explained by the rigid rule of 2s and 3s. After years of relentless data analysis and undeniable replication, the physics community was forced to admit a terrifying truth. CERN had discovered tetraquarks and pentaquarks, 4-quark and 5-quark structures. The forbidden configurations had materialized in the dark, effectively destroying the most basic categorization of physical matter. The universe had produced something that its own classical rules explicitly prohibited. These tetraquarks and pentaquarks are not just new entries in the catalogue of subatomic particles. They are the physical manifestation of a broken law. They are highly exotic, unnatural clusters of matter, tangled together in bizarre, alien geometries that theoretical physicists are still desperately trying to mathematically model. They exist for only the briefest, most infinitesimal fraction of a millisecond before the universe violently forces them to decay, tearing them apart because they are too unstable, too unnatural to survive in the cold, resting state of our modern reality. But for that microscopic sliver of time, they are undeniably real. The absolute mathematical boundary that separated the possible from the impossible was forcefully and violently breached. We must pause and violently confront the agonizing philosophical dread of what this actually means for the nature of the physical world. We have always assumed that the laws of physics are an inflexible, external framework, a rigid container that forces matter to behave in specific, unchangeable ways, regardless of the environmental conditions. But the discovery of the tetraquark and the pentaquark suggests something vastly more disturbing. It suggests that the laws of physics are not a rigid architecture, they are merely a set of habits. The rule of twos and threes is just the way matter prefers to organize itself when the universe is cold, quiet, and at rest. But when you apply absolute, apocalyptic stress to the system, when you subject the foundational building blocks of reality to unprecedented, localized torture, matter does not just passively shatter, it improvises. Under the searing, chaotic violence of the collider, the quarks are desperately trying to bind together, fighting against the tearing trauma of the impact. In their frantic, chaotic scramble to satisfy the unyielding demands of the strong nuclear force, they abandon the classical rules. They mutate. They group together in grotesque, forbidden clumps of 4 or 5, simply to hold themselves together for a fraction of a millisecond. We are watching matter actively invent unnatural, alien configurations just to survive the extreme kinetic violence we are inflicting upon it. It is a subatomic survival mechanism, a desperate, chaotic mutation occurring in the deepest, most inaccessible basement of reality. The physical substance of the universe is not a dead, passive medium. It is something that twists, warps, and fundamentally rewrites its own architectural code when it is pushed past the absolute limit of endurance. This paralyzing realization completely eradicates the comforting illusion of a stable, predictable cosmos. If the most fundamental building blocks of reality can mutate under stress, if the universe can temporarily suspend its own absolute laws to forge forbidden, alien structures in the dark, then we have absolutely no idea what the true limits of physical reality actually are. We are blindly operating a machine that tortures the fabric of space and time, completely unaware of what other impossible, grotesque configurations of matter we might eventually force into existence. We are no longer just explorers mapping a static, dead universe. We are tormentors, applying unimaginable violence to the bedrock of existence, entirely blind to the terrifying fact that the universe is actively mutating in response to our torture. The rigid, dependable reality we trust with our lives is nothing more than a fragile, temporary arrangement, and by violently shattering the rules of confinement, we are slowly, methodically teaching the cosmos how to create monsters out of the very substance of our own world. Tap your fingers against the nearest surface, a desk, a wall, your own collarbone. It feels dense, immutable, and undeniably real. We navigate our entire lives based on this fundamental assumption of solidity. We construct towering skyscrapers, we forge steel bridges, we embrace our loved ones, all under the comforting illusion that the universe is built of tangible, enduring stuff. But particle physics has long whispered a more unsettling truth. Matter is overwhelmingly empty. If you were to remove the empty space from the atoms of every human being on Earth, the entire human race would fit into the volume of a single sugar cube. So, what is it that pushes back when you strike a table? What prevents your hand from passing through it like mist? The answer is not matter. The answer is force. Specifically, the strong nuclear force, a relentless, unbreakable grip that binds the fundamental building blocks of the universe together. Deep within the heart of the atom, inside the nucleus, lie protons and neutrons, and within them, the true foundation of reality, quarks. Quarks are the quintessential particles of matter, but they are chaotic, restless, and completely incapable of remaining together on their own. They require a mediator, a cosmic adhesive to prevent the atomic core from violently tearing itself apart. Enter the gluons. As their name bluntly suggests, gluons are the glue of reality. They are the messenger particles of the strong force, passing infinitely fast between quarks, holding them in an eternal, inescapable embrace. Gluons are not matter. They possess no mass, no physical dimensions, no substance as we conventionally understand it. They are pure, unadulterated force carriers. They are verbs, not nouns. Their entire existence in the framework of the cosmos is defined by their function: to bind, to connect, to anchor the tangible world so that it does not immediately dissolve into chaotic radiation. In the standard model of physics, you cannot have a bridge without opposing shores. You cannot have a taut chain without objects to be tethered at either end. Gluons, by their very definition, are supposed to be intermediaries. They flash into existence to carry the strong force between quarks and then vanish back into the quantum foam. They are the unseen threads in the grand tapestry of existence, holding the picture together without ever being part of the painted image themselves. But what if the threads could detach? What if the glue could exist entirely independently of the objects it was meant to bind? For half a century, this terrifying question haunted the minds of theoretical physicists. It was a mathematical whisper, a strange, persistent anomaly buried deep within the complex equations of quantum chromodynamics. In the 1970s, scientists hypothesized that because gluons carry the color charge of the strong force, they could, in theory, interact not just with quarks, but with each other. They could stick to themselves. This led to a staggering, almost paradoxical proposition: the possibility of a bound state made entirely of force carriers, a structure built of pure glue with absolutely no matter inside it. They called this theoretical phantom the Odderon. The name itself reflects its strange, contrarian nature. The theory dictated that an odd number of gluons, at least 3, could entangle themselves in a coherent, albeit incredibly brief, structural state. To understand the sheer, mind-bending absurdity of this concept, imagine walking into an empty, silent room and finding the immense tension of a pulled rope suspended in mid-air, but with no rope, no hands pulling it, and no walls anchoring it, just the invisible force of tension, existing as an independent, floating entity in the void. It profoundly defies our deeply ingrained evolutionary logic of cause and effect, of substance and connection. Yet, the unfeeling mathematics of the quantum world insisted it was possible. For 50 long years, the Odderon remained one of the holy grails of high-energy physics, an elusive ghost that flatly refused to be captured. It was a theoretical necessity that simply would not materialize in our detectors. The hunt required machines of unprecedented scale and apocalyptic violence. Deep beneath the tranquil border of France and Switzerland, the Large Hadron Collider at CERN was constructed, a 27-kilometer circular tomb designed to hurl protons at each other at a fraction of a percent shy of the speed of light. When these subatomic projectiles collide, they do not merely break apart, they shatter the fabric of reality, melting into a primordial soup of pure energy and briefly recreating the exact conditions that existed fractions of a second after the Big Bang. In the microscopic aftermath of these collisions, physicists sifted through petabytes of data, searching desperately for the fleeting signature of the ghost glue. They were looking for a needle in a cosmic haystack, but a needle that ceases to exist almost the instant it is formed. When protons graze each other at these relativistic speeds, they exchange particles. Usually, they exchange an even number of gluons, a well-documented, symmetrical state known as a pomeron. But the Odderon required an odd number. It required a specific, incredibly rare asymmetry in the violent debris. Years turned into decades. Entire brilliant careers were spent chasing the shadow of this invisible particle. And then, finally, after half a century of waiting in the dark, the data aligned. Through a meticulous, exhaustive comparison of proton-proton collisions at CERN and historical proton-antiproton collisions at the Tevatron in the United States, an undeniable discrepancy emerged from the noise. The microscopic difference in how these particles scattered off each other could only be explained by one phenomenon: the brief, spectral materialization of the Odderon. The ghost had finally been caught on camera. The existence of a particle comprised of absolutely nothing but interacting gluons was confirmed as a factual reality of our universe. This monumental triumph of modern science, however, carries with it an undercurrent of profound, unshakable existential dread. The confirmation of the Odderon forces us to confront a deeply unsettling reality about the fundamental nature of our own existence. We are biologically and psychologically accustomed to viewing matter as the primary ingredient of the universe. We see the stuff of the world, the rocks, the oceans, the flesh as the main characters, with forces acting merely as secondary operators, the invisible hands that politely move the physical pieces around the cosmic chessboard. But the Odderon flips this comfortable hierarchy completely on its head. If the glue that holds reality together can detach, form its own coherent structures, and wander the quantum void as a disembodied, independent entity, then what does that make us? It suggests, horrifyingly, that force is the primary reality, and matter is simply a secondary consequence, a temporary, fragile manifestation trapped within the web of these ancient, uncaring forces. We are made of quarks, yes, but the quarks are incidental. They are essentially captive passengers, trapped in a chaotic, boiling sea of self-interacting gluons. The mass of your body, the weight of the earth beneath your feet, the immense gravitational pull of the dying stars above almost all of this mass does not actually come from the matter particles themselves. It comes from the frantic, binding energy of the gluons. You are not made of solid stuff. You are made of pure tension. You are a highly localized knot of raw energy, held together by invisible entities that, as the Odderon definitively proves, do not actually need you to exist. They can persist perfectly well on their own, floating through the absolute vacuum of space as abstract, mathematical phantoms. The physical world we touch, see, and rely upon to keep us sane is reduced to a desperately fragile illusion, a temporary coagulation of energy mediated by ghost particles. Let us delve deeper into the sheer terror of this realization. Imagine the universe not as a grand collection of celestial objects, but as a vast, empty theater where invisible actors perform an eternal, frenetic dance in the dark. The props, the swirling galaxies, the burning planets, the fragile living beings are merely accidental holographic projections created by the friction of their invisible movement. The Odderon is the ultimate, undeniable proof that the actors can perform without the props. The forces of nature are utterly indifferent to the physical forms they create and destroy. The strong force, the very anchor of tangible reality, is capable of a profound and chilling detachment. It can sever its ties to matter and exist as a self-contained paradox, a transient knot of nothingness that somehow possesses structural integrity. When you stare out into the infinite night sky, you are not just looking at a vast darkness punctuated by distant light. You are looking at an ocean filled with these wandering phantoms. Every single microsecond, in the turbulent quantum vacuums of deep space, in the crushing hearts of hypergiant stars, and even in the upper atmosphere of our own planet, where cosmic rays violently collide with the air we breathe, Odderons are flashing into and out of existence. They are the true ghost glue, the disembodied binders of worlds, living their infinitely brief, frantic lives, completely separate from the matter they were born to govern. They serve as a stark, terrifying reminder of our own ultimate impermanence. If the foundational adhesive of the universe can simply wander away, unanchored and completely free, then the comforting solidity we feel when we embrace the world is nothing more than a statistical accident. We are bound tight by invisible forces that could, in the grand, cold mathematical mechanics of the cosmos, just as easily exist without us. We are not the masters of the physical realm. We are merely temporary, incidental hostages of the strong force. Our physical bodies, our sprawling cities, our entire recorded civilization are just brief, insignificant interruptions in a universe fundamentally ruled by unseen, unfeeling energy. The confirmation of the Odderon is not merely a hard-won victory for the field of particle physics. It is a profound philosophical demotion for humanity. It brutally strips away the comforting blanket of physical reality, leaving us shivering naked in the cold, mathematical void. It whispers from the dark that the glue holding your bones together, the invisible force holding the solid ground beneath your feet, is, at its core, a phantom. And like all phantoms, it belongs to the ether, capable of existing on its own terms, completely unburdened by the fragile, illusory matter we call reality. We are left to quietly ponder our existence as momentary vibrations in a boundless sea of ghost glue, waiting endlessly for the day the universe finally decides to let go. There is a deep psychological comfort in the belief that the universe operates according to a strict, unbreakable set of rules. We build our entire understanding of reality on the foundation of physical laws that are supposed to be absolute, eternal, and perfectly balanced. We trust that gravity will always pull, that electromagnetism will always spark, and that the fundamental building blocks of matter will always behave in predictable, mathematically sound ways. For over half a century, the pinnacle of this comforting certainty has been the standard model of particle physics. It is the master equation of reality, an exquisite mathematical architecture that flawlessly categorizes every known particle and perfectly describes three of the four fundamental forces governing the cosmos. It is the source code of existence. It has survived decades of the most rigorous, punishing experimental tests humanity could devise. Predicting the existence of the Higgs boson and the precise behavior of matter, with an accuracy that borders on the miraculous. We have rested securely in the knowledge that while the universe is vast and terrifying, its underlying operating system is at least flawlessly logical. But deep within the subterranean tunnels of the Large Hadron Collider, that reassuring illusion of perfection has begun to fracture. A terrifying glitch has appeared in the code, and it revolves around a fleeting, unstable speck of matter known as the beauty quark. To understand the profound existential dread of this discovery, one must first understand a sacred, fundamental principle of the Standard Model known as lepton universality. In the incredibly complex family tree of subatomic particles, there exists a class of particles called leptons. The most famous lepton is the electron, the tiny, energetic spark that powers our civilization, binds our chemistry, and courses through the nervous systems of our own bodies. The electron has a heavier, more unstable sibling called the muon. According to the strict, uncompromising laws of the Standard Model, the electron and the muon are fundamentally identical in every single way, except for their mass. The universe, acting through the weak nuclear force, the force responsible for particle decay, is entirely blind to this difference in weight. It is supposed to treat the electron and the muon with absolute, mathematically perfect equality. Therefore, if a heavy, unstable particle decays and transforms into lighter particles, it should produce pairs of electrons and pairs of muons at exactly the same rate. This is not merely a suggestion, it is a rigid, foundational pillar of reality's architecture. The cosmic ledger must balance. The dice of quantum mechanics must not be loaded. Enter the beauty quark, also known in the sterile nomenclature of physics as the bottom quark. It is a massive, highly unstable particle that does not naturally exist in our everyday world. It is a creature of extreme violence, born only in the most energetic environments in the universe, such as the hearts of collapsing stars, the fiery aftermath of supernovae, or the deliberate, high-speed proton collisions orchestrated by humanity at CERN. Because it is so heavy and so profoundly unstable, a beauty quark exists for only a microscopic fraction of a second before it decays, tearing itself apart and transforming into a cascade of lighter, more stable particles. It is the perfect, albeit incredibly brief, testing ground for the laws of physics. By observing millions upon millions of these microscopic deaths, physicists can verify that the universe is keeping its promises. Specifically, they can watch a particle containing a beauty quark decay and count exactly how many times it produces an electron pair versus how many times it produces a muon pair. This meticulous cosmic bookkeeping is the primary mission of the LHCb experiment, a massive, highly specialized detector positioned along the 27-kilometer ring of the Large Hadron Collider. For years, the massive machine has been systematically sifting through the subatomic debris of billions of collisions, capturing the fleeting, ghostly tracks of particles born from the death of beauty quarks. The expectation was one of boring, reassuring confirmation. The data was supposed to show a perfect 50-50 split, a beautiful testament to the unwavering symmetry of the Standard Model. But as the data accumulated, a shadow fell over the pristine mathematics. The ledger was not balancing. The equations were refusing to resolve. The beauty quarks were betraying the fundamental code. The data from the LHCb experiment strongly, almost undeniably, suggests that when beauty quarks decay, they are not producing electrons and muons at equal rates. Instead, the universe appears to be playing favorites. The beauty quarks are decaying into electrons slightly more often than they are decaying into muons. It is a microscopic discrepancy, a fraction of a percentage point in the grand statistical noise of quantum mechanics. But in the realm of particle physics, this tiny tilt in the scales is nothing short of an apocalyptic earthquake. It is a mathematical impossibility according to the very laws that dictate the structure of reality. If lepton universality is broken, if the universe treats the electron and the muon differently during the fundamental process of decay, then the standard model is not just incomplete, it is fundamentally flawed. The master equation is wrong. The dread that stems from this anomaly is not the simple disappointment of an incorrect theory. It is a profound, creeping terror regarding the stability and reliability of the physical world itself. We are entirely constructed from the mathematics of the standard model. The laws that govern the decay of a beauty quark are part of the exact same intertwined code that governs the stability of the protons in our bodies, the burning of the sun in our sky, and the chemical bonds that hold the earth together. If the code is broken in one place, we are forced to confront the horrifying possibility that it is broken everywhere. The beauty quark anomaly suggests that there are unseen, undocumented forces or undiscovered phantom particles interfering with the fundamental mechanisms of the universe. It points to the existence of entirely new realms of physics, perhaps a new fundamental force, or hypothetical entities like leptoquarks or Z-prime bosons that operate completely outside our understanding, subtly pulling the strings of reality and distorting the rules we thought were absolute. Imagine discovering that the foundation of the skyscraper you live in is not made of the solid steel the blueprints promised, but of a strange, shifting alloy that engineers cannot identify and whose stress tolerances are completely unknown. That is the philosophical predicament humanity now faces. The rigid, reliable laws governing the physical world are beginning to fray at the edges. We are forced to abandon the comforting notion that we reside in a perfectly ordered, symmetrical cosmos. Instead, we are waking up to the reality that our universe might be built on a corrupted, asymmetrical foundation, a glitching matrix where the fundamental rules can bend, warp, and contradict themselves in the deep, dark corners of the quantum realm. The comforting illusion of absolute physical law is rapidly dissolving. This crack in the code implies that reality is far more chaotic, unpredictable, and potentially unstable than we have ever dared to imagine. It strips away the hubris of modern science, reminding us that our grandest, most successful theories are ultimately just fragile human models, mapped onto a universe that is vastly more alien and indifferent than we can comprehend. If the fundamental forces can play favorites, if the bedrock math can simply fail to balance, then the structural integrity of existence itself is called into question. We are adrift in a cosmos governed by a fractured rulebook, entirely at the mercy of hidden variables and unseen forces that could, for all we know, rewrite the physics of our world without a moment's notice. The beauty quark anomaly is a terrifying whisper from the subatomic void, explicitly warning us that the master equation of reality is flawed, and that the universe we thought we understood is, at its deepest, most fundamental level, operating on a broken code. We are left standing on the edge of a mathematical abyss, staring down into the terrifying realization that the ultimate nature of reality is not a perfect, elegant symmetry, but a flawed, shifting enigma that we may never truly be able to trust. There is a profound, deeply entrenched human desire to believe that our existence is intentional. We look up at the spiraling arms of the Milky Way. We observe the complex, interlocking ecosystems of our planet, and we feel the beating of our own heart, concluding that such intricate beauty must be the result of a grand, cosmic design. We desperately want to be the main event, the deliberate outcome of a universe that desired to be seen and understood. We build massive philosophies and intricate religions around the assumption that we are meant to be here. But the cold, sterile equations of quantum mechanics and cosmology offer a drastically different, profoundly more terrifying narrative. When we strip away the comforting myths and peer into the mathematical fires of the Big Bang, we do not find a universe designed for life, or even a universe designed for matter. We find a universe that was explicitly, rigidly programmed to be absolutely empty. The simple, horrifying truth is that we literally should not be here. The fact that anything exists at all is not a triumph of creation, but a microscopic, inexplicable failure of the universe to completely erase itself. This is the antimatter glitch. To comprehend the sheer absurdity of our own existence, we must confront the absolute, uncompromising symmetry that governs the fundamental laws of physics. In the late 1920s, physicist Paul Dirac formulated an equation to describe the behavior of electrons, but the mathematics stubbornly insisted on yielding two answers. One answer described the familiar, negatively charged electron, while the other described a phantom particle, identical in every respect, mass, spin, behavior, but possessing a positive charge. This was the mathematical birth of antimatter, a concept that sounded like science fiction but was swiftly confirmed as a cold, hard fact of reality. Antimatter is not merely a theoretical curiosity. It is the uncompromising mirror image of the physical world. Every single fundamental particle of regular matter, every quark that makes up your protons, every electron that fires in your neurons has an exact, oppositely charged twin. And the universe, according to our most successful, battle-tested models, is fundamentally obsessed with balance. It demands perfect symmetry. The cosmic ledger must always equate to zero. 14 billion years ago, in the unimaginably dense, hot crucible of the Big Bang, the universe was a singularity of pure, raw energy. As space itself began to violently expand and cool, this primordial energy condensed into the very first particles of mass. But the ironclad laws of quantum physics dictate that energy cannot simply choose to become regular matter. When energy transforms into mass, it must create a perfectly balanced ledger. For every single particle of matter forged in that cosmic dawn, an exact counterpart of antimatter had to be created simultaneously. The universe was born in a state of perfect 50-50 symmetry. This creates an immediate, catastrophic problem for the prospect of a physical universe. Matter and antimatter cannot coexist. They are the ultimate cosmic antagonists. When a particle of matter encounters its antimatter twin, the two do not simply bounce off one another or form a bond. They utterly annihilate each other. They vanish from existence in a violent, microscopic flash of pure radiation, converting their mass entirely back into light. This means that the birth of the universe was not a grand act of creation, but an inevitable setup for immediate, total self-destruction. The Big Bang should have been followed by the Great Annihilation. In the fractions of a second following the dawn of time, the perfectly equal oceans of matter and antimatter should have collided, mutually erasing every single particle in existence. The entire cosmos should have been an unimaginably brief flash of light, rapidly fading into a cold, eternally expanding void of nothing but dying photon. The universe was fundamentally designed to be a self-correcting equation that instantly resolved back to zero. There was supposed to be no carbon, no oxygen, no burning stars, no planets, and absolutely no biological observers to ponder the dark. The natural, intended state of reality is an infinite, silent emptiness. Yet, you are reading this. You are breathing. You exist in a universe overflowing with billions of galaxies, each containing billions of stars, all constructed from vast, enduring accumulations of regular matter. This agonizing contradiction is what drives the massive detectors at CERN, like the ALICE and LHCb experiments, to sift tirelessly through the subatomic debris of high-speed particle collisions. They are searching for the physical mechanism behind the greatest, most terrifying mystery in the cosmos, the breaking of the perfect symmetry. To explain our existence, there had to be a microscopic flaw in the universe's flawless execution of its own erasure, a tiny, inexplicable stutter in the fundamental code of reality. Physicists call this anomaly charge parity violation, but in the grand narrative of existence, it is simply the glitch. Calculations suggest that in the primordial inferno, the universe made a microscopic rounding error. For reasons that we still fundamentally do not understand, the laws of physics favored regular matter by an impossibly thin margin. For every 1 billion particles of antimatter created in the Big Bang, there were exactly 1,000,000,001 particles of regular matter. When the Great Annihilation occurred, it was a slaughter of cosmic proportions. 1 billion particles of matter met 1 billion particles of antimatter, mutually obliterating each other and filling the young universe with blinding radiation. But after the dust of creation settled, that single, anomalous, extra particle of matter was left behind, utterly alone, with no antimatter twin left to destroy it. This is the profound existential dread that lies at the heart of our origins. Everything you have ever known, every star in the night sky, every grain of sand on Earth, every monumental achievement of human history, and the very biological flesh of your own body, all of it is constructed entirely from that microscopic leftover fraction. We are the survivors of a cosmic mathematical error. The universe we inhabit is nothing more than the infinitesimal debris of a fundamentally failed annihilation. We are the 1 in a billion. But we are not special, we are a typo. Every day, we wake up and navigate a world that feels incredibly solid and overwhelmingly important. We stress over trivialities. We build monumental cities. We wage wars. And we fall in love, completely absorbed in the profound illusion of our own significance. We treat our existence as a given, a sturdy baseline upon which we build our sprawling civilizations. Yet, beneath the surface of this perceived stability lies the maddening truth of the antimatter asymmetry. To stand in the shadow of the Large Hadron Collider, to look at the towering, cathedral-sized detectors buried deep beneath the European countryside, is to witness the frantic, almost desperate human attempt to comprehend our own illegitimacy. We have constructed the largest, most complex machines in the history of our species, burning through immense reserves of power and human intellect, not to uncover a grand, divine blueprint, but simply to measure the precise dimensions of the mistake that allowed us to be born. It is a pursuit bordering on cosmic irony. We are the error, using our fundamentally flawed existence to desperately interrogate the universe about why it failed to execute its own perfect emptiness. If the universe had simply functioned exactly as its fundamental laws dictate, if the pristine mathematics of quantum mechanics had executed flawlessly without a single stutter, there would be no witness to the void. The sheer gravity of this realization is suffocating. It dictates that every single piece of matter is essentially a fugitive from the laws of physics. The protons in the water you drink, the iron in your blood, the calcium in your bones, all of these are remnants that somehow escaped the great cosmic execution. They are anomalies that survived the great annihilation not through resilience or purpose, but through a blind, statistical fluke. This drastically recontextualizes our place in the dark. We are not the masters of the physical realm. We are the ghosts of a universe that failed to die. We are biologically hardwired to find meaning and purpose in our surroundings. But the antimatter glitch brutally strips away this comforting hubris. It forces us to confront the reality that we are not the intended outcome of reality. The universe did not want us here. The cosmos was designed to be a perfect, empty void, an elegant, balanced equation resolving into absolute nothingness. Our sprawling, noisy, matter-filled universe is an aberration. It is a deviation from the cosmic norm. When you look at your own hands, you are not looking at a miracle of purposeful design. You are looking at a localized manifestation of a primordial mistake. The structural integrity of reality is built upon a foundation of fundamental imbalance. We are a rounding error that somehow managed to spiral out of control, coalescing into galaxies, planetary systems, and conscious beings capable of looking back at the void and realizing we were never meant to be. The ultimate terror is not that the universe is hostile, but that it is entirely accidental. We are adrift in an immense cosmos that is fundamentally a dead space, populated entirely by the anomalous refuse of a broken symmetry. Our existence is a brief, microscopic glitch in the eternal dark, a fleeting mathematical error waiting, ultimately, for the day the universe finds a way to correct its ledger and finally return to the perfect, empty silence it always intended. From the moment we are old enough to hold two magnets in our hands, we are introduced to one of the most comforting, unbreakable rules of the physical universe. We feel the invisible phantom pressure as two north poles repel each other, and we feel the sudden, satisfying snap as a north and a south pole violently attract. This fundamental interaction defines our understanding of the electromagnetic force. We are taught that these magnetic poles are inextricably linked, bound together in an eternal, inescapable partnership. If you take a bar magnet and snap it in half, you do not isolate the north from the south. The universe instantly heals the fracture, creating two perfectly complete, smaller magnets, each possessing its own north and south pole. The invisible magnetic field lines that govern this force are perfect, unbroken loops. They arc out from the north, travel through the void, and always, without fail, return to the south. This continuous, unbroken cycle is the bedrock of classical physics. It is an infinite loop that implies safety, stability, and a profound underlying order to the cosmos. The magnetic field has no beginning and no end. But deep within the subterranean tunnels of CERN, physicists are actively hunting for a particle that shatters this comforting illusion. They are searching for the magnetic monopole, a hypothetical, impossible ghost that threatens to unravel the very fabric of our physical reality. The magnetic monopole is exactly what its name suggests: an isolated, singular magnetic charge. It is a solitary north pole without a south, or a solitary south pole wandering the universe without a north. In the rigid framework of classical electromagnetism, such an entity is an absolute absurdity. James Clerk Maxwell, the brilliant architect of the equations that govern light and magnetism, explicitly forbade their existence. His mathematics declare that magnetic field lines cannot simply end, they must form closed loops. To imagine a monopole is to imagine a piece of string with only one end, or a shadow cast without a light source. It defies our most basic, evolutionary logic of how the physical world operates. Yet, the strange, counterintuitive realm of quantum mechanics paints a vastly more terrifying picture. In the early 20th century, theoretical physicist Paul Dirac demonstrated that if even a single magnetic monopole exists anywhere in the vast, cold expanse of the universe, it perfectly explains why electric charge comes in discrete, quantifiable packets. The uncompromising mathematics of quantum theory do not just allow for the existence of the monopole, they practically demand it as the hidden price for the structure of our reality. The monopole is the dark, silent secret necessary for the universe to function. To capture this theoretical phantom, the Monopole experiment was constructed at the Large Hadron Collider, standing in stark contrast to the colossal cathedral-sized detectors like ATLAS and CMS, which rely on massive arrays of active electronics to record the chaotic debris of shattered protons. Monopole is ominously quiet. It is essentially a passive trap, a dense, silent array of specialized plastics and aluminum suspended in the dark. It is not designed to measure the standard, symmetrical splash of ordinary particles. It is waiting to record the devastating, microscopic scorch mark of a monster. A magnetic monopole, if created in the apocalyptic energy of a proton collision, would be unimaginably heavy and heavily ionizing. It would rip through the plastic sensors like a cosmic bowling ball, leaving a permanent, destructive trail in its wake. Monopole is a hunter's snare set at the edge of human knowledge, waiting for a creature that fundamentally breaks the rules of existence to step into the light. The profound, suffocating dread surrounding the magnetic monopole does not come from the particle itself, but from what its existence implies about the fragility of our world. We rarely pause to consider the immense, invisible scaffolding that prevents our bodies from spontaneously dissolving into the ether. You are not a solid object. You are a sprawling, unimaginably complex galaxy of atoms. At the core of every atom is a dense nucleus, and orbiting that nucleus is a restless swarm of electrons. What keeps those electrons tethered? What prevents them from simply flying off into the void, turning your biological form into a chaotic, formless cloud of radiation? It is the electromagnetic force. It is the invisible web of continuous, unbroken field lines that govern the interactions of charged particles. Electromagnetism is the absolute boundary of physical touch. It is the force that pushes back when you strike a wall, the force that binds your DNA, and the invisible armor that maintains the structural integrity of every single object in the visible universe. We exist, and we persist, entirely because we trust that these electromagnetic tethers are infinite, unbreakable loops. The discovery of a magnetic monopole would be the ultimate proof that these invisible threads can be cut. Because a monopole is an isolated point of magnetism, its field lines do not loop back upon themselves. They radiate outward in straight lines, extending infinitely into space, and they never return. They are the severed ends of reality. If a magnetic field line can have an open end, it means the fundamental force holding our atoms together is not an invincible, continuous shield. It is a fragile net that can be unspooled. When an isolated magnetic charge passes through regular matter, it acts as an ontological shears. It does not merely push atoms aside, its sheer, asymmetrical magnetic power fundamentally distorts and severs the electromagnetic bonds that maintain atomic stability. The existence of the monopole implies that the invisible laws keeping our physical structure intact are not absolute decrees of nature, but temporary, vulnerable arrangements that can be violently undone. Imagine the universe not as a robust, solid construction of steel and stone, but as an infinitely intricate tapestry woven from a single, continuous, invisible thread. As long as the thread remains unbroken, the tapestry holds its shape, displaying the beautiful, complex patterns of stars, planets, and biological life. We live our lives resting securely on the surface of this fabric, trusting in its permanence. But the magnetic monopole is the ultimate loose end. It is a glaring, impossible flaw in the weave. If you find a loose thread and apply even the slightest tension, the entire grand tapestry begins to unravel. The intricate patterns disintegrate, the structure fails, and the beautifully organized creation collapses back into a shapeless, chaotic pile of raw string. The hunt at CERN is fundamentally a search for the cosmic scissors that can enact this exact unraveling upon our reality. The sheer terror of this concept strips away the comforting illusion of our physical permanence. We are biologically conditioned to fear physical threats, predators, fire, the crushing weight of falling debris. But these are macroscopic dangers that simply rearrange the matter of our bodies. The magnetic monopole represents a threat of an entirely different, unfathomably deeper magnitude. It threatens the very concept of matter itself. If the modal experiment ever successfully captures the devastating track of a monopole in its silent plastic sheets, it will serve as the ultimate, horrifying revelation that we are entirely unprotected in the dark. It will prove that the forces we rely upon to maintain our physical form, the invisible loops of magnetism that hold the atoms of our hearts and minds together, possess fatal, severable flaws. We would be forced to look out into the cosmos with a new, paralyzing understanding of our own fragility. We would know that drifting through the silent vacuum of space, hidden amongst the cosmic rays and the dark matter, are ancient, isolated charges capable of slicing through the fundamental fabric of our world. They are the rogue executioners of the quantum realm, unbound by the rules of symmetry, carrying the power to unlace the electromagnetic bonds that keep the universe from falling apart. The confirmation of the magnetic monopole would brutally demote physical reality from an enduring, solid truth to a temporary, highly precarious state of suspense. It leaves us standing on a precipice, staring into the terrifying possibility that the entire physical universe, with all its vibrant life and enduring structures, is suspended by invisible strings that can, at any moment, simply be snipped. We are left to exist in a state of suspended animation, silently hoping that the severed ends of reality never wander close enough to pull the thread that unravels everything we are. There is a fundamental psychological need deeply embedded in the human mind to categorize the world. From the moment we develop consciousness, we survive by drawing strict, impenetrable lines between different states of reality. We separate the hot from the cold, the living from the dead, the solid ground beneath our feet from the thin air we breathe. This desperate need for order scales all the way up to our grandest scientific endeavors. When we peer into the deepest, most foundational architecture of the universe, we demand the same rigid classification. For decades, the standard model of particle physics has provided us with exactly that: a beautifully organized, perfectly compartmentalized catalog of reality's building blocks. At the very core of this comforting model is a massive, indestructible wall separating the two primary families of matter. On one side of the wall reside the quarks. These are the heavy, sociable particles that bind together in groups to form the dense, immovable core of every atom in the universe. They are the protons and neutrons, the heavy lifting of physical mass. On the other side of the wall live the leptons, the most famous of which is the electron. Leptons are the solitary, frantic dancers, the light and energetic sparks that orbit the heavy nucleus, making chemistry, electricity, and the very sparks of human consciousness entirely possible. The quark and the lepton are the bedrock of our existence, and their roles are rigidly, eternally defined. The proton provides the anchor, the electron provides the action. They interact, they exchange invisible forces, but they never, under any circumstances, cross the boundary. A quark is a quark, and a lepton is a lepton. This strict, unyielding separation is the absolute guarantee that atoms do not randomly collapse. It is the reason chemical bonds hold together. It is the reason your DNA maintains its helical shape. We exist solely because the fundamental particles of matter possess an absolute, unwavering identity. But the recent, deeply unsettling anomalies bleeding out of particle colliders are threatening to tear this absolute wall completely down. To resolve the terrifying discrepancies observed in the decay of heavy particles, theoretical physicists have been forced to propose the existence of a nightmare entity. They call it the Leptoquark. It is a hypothetical, chimeric particle that does not merely bend the rules of the standard model. It fundamentally shatters the concept of subatomic identity. The Leptoquark is exactly what its name implies: a monstrous, impossible bridge between the completely isolated realms of quarks and leptons. In the clean, perfectly categorized universe we thought we inhabited, particles are forbidden from changing their fundamental families. An electron cannot suddenly decide to become the heavy, nuclear stuff of a proton, but the intricate, desperate mathematics required to fix the recent anomalies demand that this strict prohibition is nothing more than a fragile illusion. If the Leptoquark exists, it serves as an active, fluid conduit that allows matter to completely lose its defined identity. It means a quark, residing deep within the stable heart of a carbon atom in your flesh, could emit a leptoquark and instantaneously transmute into a fleeting, solitary electron. Conversely, an electron buzzing through the neural pathways of your brain could absorb this phantom particle and suddenly morph into a heavy, tightly bound quark. The rigid categories of matter that dictate the shape and function of the entire physical universe are reduced to mere suggestions. The wall is not made of indestructible cosmic concrete. It is a highly permeable, dangerously temporary membrane. The horror of the Leptoquark anomaly lies in its profound implications for the structural integrity of the physical world. We navigate our lives, assuming that the matter constituting our reality is permanent. We trust the steel of our bridges, the stone of our mountains, and the very biological tissues of our own bodies, because we implicitly believe their fundamental ingredients are eternally locked into their roles. Biology itself is an unimaginably complex, delicate machine, completely dependent on the absolute reliability of chemistry, which is, in turn, entirely dependent on the strict, predictable behavior of electrons orbiting stable protons. If an electron remains an electron forever, the machine continues to function. But the Leptoquark introduces a terrifying, fluid chaos into the very foundation of existence. It suggests that the basic building blocks of reality are not distinct, solid archetypes, but rather a single, murky spectrum of shifting identities. To understand the sheer existential dread of this concept, imagine constructing a towering, intricate skyscraper where you fundamentally cannot trust the building materials. You have built your floors out of solid steel and your windows out of glass, but because of a hidden, fatal flaw in the universe's physics, the steel can spontaneously decide to become glass, and the glass can randomly morph into steel. The structural failure would be catastrophic and instantaneous. This is the existential precipice upon which humanity now stands. The Leptoquark implies that the universe is not constructed from reliable, distinct pieces, but from a primordial, shape-shifting clay that only temporarily pretends to have rigid form. If fundamental particles can fluidly change their identity, then the stability of our physical bodies is nothing more than a temporary, highly precarious accident. We are not solid monuments of biology. We are precarious thermodynamic arrangements waiting to dissolve. Every single atom in your body, the oxygen in your lungs, the iron carrying blood to your heart, the calcium hardening your bones, is maintained by an unspoken, ancient treaty between quarks and leptons. The Leptoquark is the cosmic mechanism by which this treaty is violently, unpredictably broken. This introduces the ultimate terror of particle physics, proton decay. For nearly a century, we have believed that the proton is the most stable object in the universe, boasting a lifespan vastly longer than the current age of the cosmos itself. But if a quark inside a proton can spontaneously morph into a lepton via a leptoquark, the proton dies. It shatters from the inside out, releasing a microscopic burst of radiation and leaving nothing behind but scattered, unanchored energy. If proton decay is real, it means that matter itself has an expiration date. While the mathematics suggest that such identity-shifting transmutations might currently be incredibly rare, the mere fact that the boundary can be breached fundamentally alters our entire relationship with physical reality. It means that deep within the quantum static of your own cells, the potential for spontaneous, catastrophic dissolution is always present, ticking away like an invisible cosmic clock. The fundamental forces are not just interacting peacefully, they are actively suppressing the innate, chaotic desire of matter to lose its form. We are forced to view our existence not as a stable, guaranteed state of being, but as a fleeting, incredibly lucky suspension of a much deeper, underlying fluidity. We are biological manifestations of a mathematical loophole, intricate statues carved out of water, desperately holding our shape in a universe that fundamentally allows for our instantaneous, spontaneous dissolution. The dread deepens when we consider the broader cosmological implications of a universe infected by leptoquarks. The cosmos we observe, with its majestic spiral galaxies, burning hypergiant stars, and intricate planetary systems, is entirely defined by the distinct interactions between these seemingly separate categories of matter. Gravity pulls the heavy quarks together into massive stellar cores, crushing them until they ignite, while electromagnetism commands the lighter leptons to spark and radiate that blinding light out into the dark void. If the lines between these categories are fundamentally blurred, if the universe treats them as interchangeable disguises rather than absolute truths, then the entire grand architecture of the cosmos is essentially a fragile, temporary illusion. The Leptoquark whispers from the dark that in the extreme, violent environments of the universe, or perhaps in the unfathomably distant future, as the cosmos slowly ages and cools, the boundaries defining matter will eventually erode completely. All the distinct, beautiful complexity of the physical world will seamlessly bleed together. Stars will dissolve, planets will evaporate, and the complex chemistry required to harbor life will revert into a sterile, featureless soup of undifferentiated quantum static. We are left to grapple with a terrifying, absolute demotion of our own physical reality. The comforting, rigid laws of nature that humanity has spent centuries meticulously deciphering and relying upon to build our civilization are suddenly exposed as mere approximations. They are local, temporary rules that hide a profoundly unstable, shape-shifting core. The Leptoquark anomaly brutally strips away the comforting blanket of permanence, leaving us shivering in the face of atomic uncertainty. It forces us to confront the terrifying possibility that the ground beneath our feet, the air we breathe, and the very flesh of our own hands are merely temporary, coincidental alignments of identity that the universe has not yet bothered to erase. The rigid, dependable categories of matter that make our biology, our history, and our future possible are a grand, elaborate cosmic illusion. They mask a chaotic, fundamentally fluid reality where absolutely nothing is truly permanent, and where the bedrock of existence itself is constantly, silently threatening to blur back into the primordial dark. Imagine for a moment that you are standing in the center of a pitch-black, infinitely large warehouse. You cannot see your own hands, let alone the walls or the ceiling. To understand what is inside this vast darkness, you have built a massive, hypersensitive ear, a digital organ that can hear the collision of two dust motes from a mile away. You sit in a control room, watching a screen that translates every vibration into a line on a graph. Most of the time, the graph is a flat, predictable hum. This is the background noise of the universe, the expected static of reality. But every so often, the needle jumps. There is a sudden, violent spike at a frequency that shouldn't exist. It is a loud, solitary thud in the dark. You wait for it to happen again, but there is only silence. You check your cables, you recalibrate your sensors, and you tell yourself it was just a glitch, a loose wire, a stray cosmic ray, a phantom in the machine. You have to believe it was an error, because if that sound was real, it means there is something in the warehouse with you that is far larger and far stranger than anything you are prepared to face. This is the daily reality of the physicists at CERN, and the thuds they are hearing are the ghost signals of the subatomic world. At the heart of the Large Hadron Collider, 40 million times every single second, two bunches of protons are slammed together at near light speed. These collisions are not mere impacts. They are local ruptures in the fabric of space-time, brief moments where the energy density is so high that the vacuum itself boils over, birthing a chaotic spray of particles. To capture this wreckage, we have built detectors the size of cathedrals, layered with millions of sensors, designed to track the trajectory, energy, and identity of every outgoing fragment. The sheer volume of data generated is unimaginable. It is a petabyte-scale blizzard that would overwhelm any computer system on Earth if we tried to record it all. To survive this data flood, we used what is called a trigger system, a sophisticated, automated gatekeeper that makes a split-second decision on which collisions are worth keeping and which are trash. We have programmed these gatekeepers with the standard model, the master list of everything we know to exist. We essentially tell the machine to look for what we expect and to discard the rest as meaningless noise. But this raises a terrifying philosophical question. If we have taught the machine to only value the familiar, how will we ever recognize the truly alien? Occasionally, despite our rigorous filters, something impossible slips through. In the clean, orderly histograms of particle physics, researchers sometimes see a bump. A bump is a localized cluster of data points that sit higher than the predicted background curve. It is the subatomic equivalent of a footprint in the sand where no one was supposed to be walking. These bumps often appear at incredibly high energy levels, suggesting the brief existence of particles so massive they defy our understanding of how the universe should be structured. In the history of the collider, there have been several such ghosts. There was the famous 750 GeV diphoton excess, a sudden surge in the data that suggested a new, heavy particle was manifesting in the debris. For a few months, the physics community held its breath. Hundreds of theoretical papers were written to explain what this entity could be. And then, as more data was collected, the bump slowly smoothed out. It faded back into the background static. The official verdict was statistical fluctuation. It was just the universe playing a trick on our eyes, a random alignment of noise that looked, for a fleeting moment, like a signal. But there is a growing, quiet dread among those who stare at these screens late into the night. What if the bump didn't disappear because it was fake? What if it disappeared because we are only seeing the brief, flickering shadow of something that doesn't belong in our four-dimensional reality? We use a mathematical concept called sigma to determine the certainty of a discovery. To claim a new particle exists, you need a 5 sigma result, a 1 in 3 million chance that the signal is a fluke. It is a high bar, designed to protect the integrity of science. But this reliance on statistical perfection acts as a psychological safety net. It allows us to gaslight ourselves. When a 3 sigma or 4 sigma bump appears something with a 1 in thousands chance of being an accident, we label it noise to avoid the shattering implications of what it would mean if it were real. We are essentially staring at digital footprints of monsters and convincing ourselves we just have a dirty lens. The dread stems from the nature of these signals. They are often too heavy. They don't decay into the particles they should, and they appear in regions of the energy spectrum that should be a desert. If these signals are real, they represent a class of matter that doesn't just expand the standard model, it burns it down. They could be the first evidence of dark matter particles finally interacting with the light, or perhaps echoes from a hidden sector of the universe that operates on an entirely different set of physical laws. They might be Kaluza-Klein states particles that are actually vibrations from higher spatial dimensions, briefly leaking into our world before snapping back into the bulk. When we see a ghost signal, we are potentially looking at a glitch in the matrix of our universe, a moment where the fundamental code fails to hide the vast, alien complexity that exists just beyond our perception. There is a distinct human element to this horror. Imagine being the scientist who first spots the anomaly. You are looking at a line on a screen that represents the culmination of billions of dollars, decades of engineering, and the collective intellect of thousands of people. You see a spike where there should be a valley. Your heart rate quickens. You know that if this is real, everything we thought we knew about the universe is wrong. But you also know the weight of the institution. You know that if you scream discovery and the next week of data washes it away, your career is marked by the stigma of the false positive. So, you wait, you keep silent. You watch the anomaly with a mixture of awe and terror, secretly hoping it goes away, so you don't have to deal with the consequences of a broken reality. This is the look elsewhere effect in action, a statistical correction that essentially says the more places you look for a ghost, the more likely you are to see one. It is a ritual of skepticism designed to keep us sane, but it also acts as a veil, allowing us to ignore the things that go bump in the dark. What if the noise is actually the most honest part of the data? We have spent centuries perfecting a physics of the signal, the things that are repeatable, predictable, and measurable. We have built a civilization on the logic of the visible. But as our machines become more sensitive, we are beginning to realize that the signal might be a tiny, local fluke, a thin veneer of order stretched over an ocean of chaotic, non-human noise. The ghost signals at CERN are the cracks in that veneer. They are the moments where the machine, unburdened by human bias or evolutionary survival instincts, records something that simply is not supposed to be there. We call them glitches because the alternative that our universe is being haunted by massive, unrecognizable entities from a hidden dimension is too much for the human psyche to bear. We find ourselves in a state of perpetual, high-tech gaslighting. We build larger and larger colliders, hoping to find the next big thing. But when the machine actually shows us something we don't recognize, we immediately work to debunk it. We are like children whistling in the dark to keep the monsters away. Except our whistling is complex calculus, and our darkness is the heart of a superconducting magnet chilled to colder than deep space. The dread is the realization that the detectors are not failing, they are working perfectly. They are picking up the digital footprints of things that do not obey our physics, things that do not care about our sigma levels or our Nobel Prizes. We are desperately trying to preserve the sanctity of our own universe by writing off the truth as an error. But as the data continues to pour in, and as the bumps continue to appear in the silent, forbidden corners of the energy spectrum, the glitch narrative is becoming harder to maintain. We are staring at a screen that is telling us, in the cold language of electricity and light, that we are not alone in the warehouse. The signals are real. It's our sanity that is the illusion. We are just waiting for the day when a bump doesn't fade away, the day the ghost refuses to leave, and we are forced to admit that the machine isn't glitching. It's finally seeing the world for what it truly is. Most people wake up every morning with an implicit, unshakable trust in the ground beneath their feet. not just the floor of their bedroom or the pavement of the street, but the very structural integrity of the vacuum itself. We have been raised to view the emptiness of space as a passive, hollow stage, a silent theater where the drama of matter and light plays out. In our everyday logic, a vacuum is simply the absence of things. It is zero. It is the baseline. But modern physics has revealed a much more predatory truth. The vacuum is not empty, and it is certainly not passive. It is a living, tension-filled medium governed by the Higgs field, an invisible permeate that acts as a sort of cosmic molasses, dragging against particles and granting them the property we call mass. This field is the silent architect of our physical reality. Without its constant, unwavering pressure, every atom in your body would lose its weight and dissolve into a burst of radiation traveling at the speed of light. The stability of everything you have ever loved is tethered to the baseline state of this field. But we are beginning to realize that this baseline might be a lie. To understand the precariousness of our situation, imagine a ball resting in a shallow dip halfway up the side of a massive mountain. To the ball, life feels stable. It isn't moving, it feels at rest. It has no reason to believe that its environment is anything other than permanent. But the true bottom of the mountain, the lowest possible energy state, is thousands of feet below. Our entire universe exists in that shallow, elevated dip. This is what physicists call a false vacuum. We are living in a temporary bubble of stability, protected only by the hill of energy that prevents our reality from rolling down into the true abyss. As long as the Higgs field remains in this specific state, the laws of chemistry, biology, and gravity function as expected. But the math suggests that the hill is not insurmountable. Our universe is a house of cards built on a frozen lake, and at CERN, we are currently jumping on the ice with the full weight of human curiosity. The quest to discover the fundamental secrets of the cosmos requires us to act as active, violent interrogators of the vacuum. To force exotic, heavy, and impossible particles like the Odderon or the hypothesized Leptoquark into our reality, we must generate localized energy densities that are nothing short of apocalyptic. We take the kinetic energy of a freight train and crush it into a space smaller than a single subatomic particle. At the precise moment of collision, the energy is so concentrated that it creates a violent, localized fluctuation in the Higgs field itself. We are essentially screaming at the vacuum, demanding that it cough up particles that haven't existed in the natural world since the first trillionth of a second after the Big Bang. We are forcing the vacuum to boil in a microscopic point, creating a frenzy of activity that the universe, in its current stable epoch, is no longer designed to handle. This is where the dread truly takes root. Think of the Higgs field as that sheet of ice covering a dark, bottomless lake. The ice is the false vacuum. It is thick enough to support our cities, our oceans, and our lives. But every time the Large Hadron Collider reaches a new energy record, we are dropping a massive, unnatural weight onto that ice. We are stressing the foundation of the cosmos in ways that are fundamentally foreign to the modern universe. We are introducing unnatural weights particles of such immense mass and strange properties that the local field must warp and buckle to accommodate them. We are essentially testing the structural limits of reality without a blueprint. We are leaning our entire weight against the glass, fascinated by the beautiful patterns of the cracks, completely blind to the exact moment the glass will shatter. The terror of a vacuum fluctuation is that it is a binary event with no middle ground and no warning. If we push the Higgs field just a fraction too far, if we provide just enough energy in just the right configuration to allow a single point of space to tunnel through the energy barrier, we trigger a vacuum decay. This is the ultimate reset button for the universe. A single microscopic bubble of the true vacuum would materialize at the point of impact. Because the true vacuum is a lower energy state, it is more stable than our world, and it would immediately begin to devour the false vacuum around it. This bubble would expand outward in every direction at the speed of light. Inside this bubble, the laws of physics are fundamentally rewritten. The Higgs field takes on a new value. The strong force, the weak force, and electromagnetism are altered beyond recognition. As this bubble wall sweeps over our solar system, it would be the ultimate silent apocalypse. Because the destruction travels at the speed of light, no signal could ever precede it. There would be no flash in the sky, no gravitational warning, and no time for the nervous system to register a change. One moment, there is a vibrant civilization pondering the mysteries of the atom. The next, the very concept of an atom is a physical impossibility. The atoms of your body would not just break apart. They would cease to be atoms entirely. The particles that compose your brain, your memories, and your loved ones would lose their mass and identity, dissolving into a cold, unrecognizable soup of new physics. The universe wouldn't be destroyed in the traditional sense. It would simply be updated to a version where humanity is a forgotten rounding error. There is a staggering hubris in our current scientific trajectory. We operate under the evolutionary assumption that the universe is a robust, permanent fixture. We assume that because the stars have burned for billions of years, the ice must be infinitely thick. But the stars exist in the natural vacuum. They do not concentrate energy with the surgical, artificial precision of a superconducting magnet. We are like children playing with a blowtorch inside a cathedral made of dry parchment, convinced that because the building hasn't caught fire in the last hour, it must be fireproof. We are so focused on the ghosts, we are hunting the exotic particles and the hidden symmetries, that we have stopped considering the integrity of the floor we are standing on. We celebrate each new, heavy particle as a triumph of human intellect, a profound weight added to our knowledge, without ever stopping to ask how much weight the vacuum can actually carry before it gives way. The dread is compounded by the fact that we are performing these experiments in total darkness. We have no stress gauge for the Higgs field. We don't know if we are operating at 1% of the breaking point or 99.9%. We are flying a plane into a storm without an altimeter, guessing our distance from the ground by the sound of the wind. We tell ourselves that cosmic rays perform higher energy collisions in the upper atmosphere all the time, which is our favorite shield against criticism. But cosmic ray collisions are messy, random, and fleeting. They are not the sustained, focused, and intelligently directed energy densities we create in the tunnels of CERN. We are doing something fundamentally different. We are applying stress with intention and repetition. We are looking for the soft spots in reality's code, and we are doing so with a cosmic scale sledgehammer. Perhaps the most unsettling realization is that our very existence is defined by this precarious tension. We are a localized fluctuation ourselves, a temporary, beautiful accident born from a specific, fragile setting of the Higgs field. We are like the intricate frost patterns on a window pane in the middle of a winter night. We spend our lives marveling at the complexity of the frost, studying the shapes of the ice crystals, and trying to understand the laws that govern our frozen world. But we are doing so while simultaneously lighting a fire against the glass to see what's on the other side. The discovery of the Odderon, the search for the magnetic monopole, the hunt for the Leptoquark. These are all attempts to understand the water beneath the ice. But in our desperation to see the water, we are melting the only thing that keeps us from drowning. We are left standing at the edge of the ultimate experiment, staring into the heart of a machine that can recreate the conditions of the beginning of time. We find ourselves in a race between our capacity for wonder and the fundamental fragility of the vacuum. The ghost signals and the mathematical ghosts we've chased for half a century have led us to this point. The realization that reality is not a solid fact, but a high-tension state of suspense. We are the architects of our own uncertainty, stressing the foundation of the cosmos in a blind search for the breaking point. Every time the beams circulate, every time the magnets cry out with the strain of the current, we are asking the universe how much it can endure. And the most terrifying part of that question is that we will only receive an answer when it is far too late to hear it. We are a civilization built on a whisper, desperately shouting into the void, hoping that the ice holds for just one more collision. For over half a century, the human race has lived under the comforting shadow of a singular, magnificent achievement: the standard model of particle physics. It is, by any objective measure, the most successful and rigorously tested intellectual framework in our history. It is the ultimate rulebook, a grand mathematical ledger that accounts for every grain of matter and every flicker of force that governs the visible universe. For decades, it felt as though we were finally approaching the end of physics. We had categorized the quarks, harnessed the leptons, and even captured the elusive Higgs boson, the God particle that supposedly completed the puzzle. We sat at the pinnacle of our own hubris, believing that while the universe was vast and complicated, its underlying operating system was essentially a finite, solvable equation. We rested in the warmth of this predictable, symmetrical world, trusting that the rules we had written down were the actual, absolute laws of nature. But as the immense machines at CERN have pushed deeper into the subatomic dark, that warmth has begun to evaporate. The rulebook is not just being revised, it is being systematically dismantled. We are discovering that the standard model was never the final truth. It was a simplified bedtime story, a crude map drawn by explorers who never realized they were only standing on a tiny, sunlit island in the middle of a vast, predatory ocean. The death of the standard model is not a sudden, loud event, but a slow, agonizing realization that the foundation beneath our feet is a hollow shell. The anomalies we have uncovered, the disembodied existence of the Odderon, the defiant behavior of the beauty quark, the terrifying potential of the Leptoquark, and the lingering, impossible ghost signals are the mathematical autopsy reports of our current understanding of reality. They are not minor glitches that can be ironed out with a few extra variables. They are fundamental contradictions that prove our master equation is incomplete, perhaps even fundamentally flawed. We have spent billions of dollars and decades of human effort trying to prove that the universe makes sense, and in doing so, we have accidentally proven that it doesn't, at least, not in any way that is compatible with human logic. We are staring at a cosmic ledger that refuses to balance, a reality where the glue of matter can exist without the matter, and where the fundamental categories of existence are beginning to blur into a chaotic, unrecognizable soup. The profound dread of this moment comes from the realization that we have successfully dismantled the only guide we ever had. We have spent centuries digging through the comfortable, predictable layers of classical physics, chemistry, and biology, stripping away the mysteries of the macro world until we reached the bedrock of the quantum realm. We thought that by reaching the bottom, we would find the ultimate elegant truth, the theory of everything, that would finally explain why we are here. Instead, we have kept digging until we fell through the floor. We have hit the abyss underneath. Beneath the standard model lies a territory where nothing makes sense, where the universe is governed by laws that actively defy human comprehension. We are beginning to suspect that the laws we've spent our history worshipping are merely local, temporary accidents, statistically convenient habits of a much larger, darker, and more alien cosmos that operates on a logic we are biologically incapable of understanding. Think of the existential vertigo that comes with this realization. Imagine being a mariner who has spent his entire life studying the currents, the winds, and the stars, convinced he understands the absolute mechanics of the sea. Then, one day, he looks over the side of the boat and realizes the water isn't water at all, but a shimmering, optical illusion, masking a depth of dimensions and entities that don't even obey the concept of wetness. That is where we are in our scientific journey. We have reached the limits of our cognitive evolution. Our brains were designed to survive on a three-dimensional plane, to calculate the trajectory of a thrown rock or the ripening of a fruit. We were never meant to perceive the ghost glue or the magnetic scissors that can sever the field lines of reality. The fact that we have even managed to detect these anomalies is a testament to our curiosity, but the fact that we cannot explain them is a reminder of our fundamental inadequacy. We are ants trying to understand the architecture of a supercomputer. We can feel the heat of the processors and detect the vibration of the fans, but the internal logic, the code itself, is an unfathomable abstraction. This void beneath suggests that our universe is much darker and stranger than the standard model ever allowed us to dream. It implies that there are dark sectors, entire families of particles and forces that do not interact with light, do not care about our gravity, and do not follow our rules of cause and effect. They are moving through us at this very moment, disembodied ghosts of a physics that we have no name for. The standard model gave us the illusion that we lived in a brightly lit room. Now, the lights are flickering out, and we are realizing that the room has no walls, no ceiling, and the floor is made of a fragile, shifting energy that could reset itself into a new, uninhabitable configuration without a moment's notice. The stability of our existence is revealed to be a microscopic, lucky fluctuation in a sea of chaotic energy that has no interest in our survival or our understanding. There is a terrifying loneliness in this new era of physics. For the first time in history, we are moving away from clarity and toward a deeper, more permanent mystery. In the past, every anomaly eventually led to a better theory. Newton led to Einstein, Bohr led to Feynman. But the current anomalies at CERN seem to point in a different direction, not toward a new, more elegant model, but toward the realization that the universe is inherently messy, asymmetrical, and perhaps fundamentally unlearnable. We are entering a dark age of science, not because we lack data, but because we have too much data that contradicts our capacity for reason. We have reached the point where the machine is telling us things that our language cannot even describe. We are witnessing the final, slow-motion collapse of the idea that the universe was built for us to understand it. As we look back at the 50 years of the Standard Model, it feels like looking back at a childhood home from the vantage point of a cold, indifferent wilderness. The house was small, and the rules were simple, but it felt safe. Outside, in the void beneath, the wind is blowing through the cracks in reality. We see the footprints of the Odderon, we hear the whispers of the Leptoquark, and we feel the localized stress of a vacuum that is tired of our interference. We have reached the end of the map. From here on out, there are no more familiar landmarks, no more reliable rulebooks, and no more comforting symmetries. We are adrift in a cosmos that is under no obligation to make sense to us. We have successfully unmade our world, and now we must learn to live in the silence of the abyss, watching the ghost signals flicker on the screen, waiting to see what the next collision reveals about the terrifying, beautiful, and utterly alien reality that has been hiding in plain sight all along. It is a lot to carry, the weight of a dying model and the birth of a mystery that might never be solved. But perhaps there is a strange, dark kind of peace in finally admitting how little we truly know. We are a small, fragile species that managed to peek behind the curtain of creation, and if what we saw was a chaotic, unfeeling void, at least we had the courage to look. The journey doesn't end here. It simply changes its nature. We stop being the masters of the house and start being the curious ghosts in a much larger, stranger haunting. There is so much more to see and so much more to fear in the experiments to come. But for now, the beams have stopped circulating, the magnets are cooling down, and the data is being archived for another day of interrogation. The mysteries aren't going anywhere. They've been waiting for us for 14 billion years. Good night, and see you in the next video.